I'm going to take you to the history of geometry, and when we talk about history of geometry, there's only one great Greek mathematician which comes to our mind, and is nothing but this mathematician named Euclid, and he is called as the father of geometry. And believe me, something great for geometry. He created a book, and what he did in this book is he gathered all, assimilated all, accumulated all the theories of great mathematicians like Hippocrates, Eudoxus, Pythagoras, Thales, and assembled everything in one book. And that book is nothing but called as Elements. It is named as Euclid's Elements. And this book has a lot of definitions, it has axioms, it has postulates, it has theorems. Now you would be wondering, we know what are definitions, but what are axioms, what are postulates? Let's learn that. It's very simple. He made this geometry very easy, and that geometry is called as Euclidean geometry, which we learned today. Let's discuss something very interesting, very simple. I give you a point and I'm asking you a question. How many lines can you draw passing through this point? Observe. 1, 2, 3, 4, 5, 6. How many? You can't count. It can be infinite. That is, what is a statement we can make in English? We can make a statement that infinite number of lines pass through a given point. Now for making this statement, do we require any proof? No. We just saw it and we accepted it. Yes, it is true. Right? Okay. I'll give you one more. I give you a point here, I give you another point. So that means I've given you two distinct points. And through the two distinct points, tell me how many lines can you draw passing through both of them? Tell me. One? Can you draw one more? Can you draw one more? No. That means you're making a statement that one and only one line passes through two distinct points, isn't it? Now when you look at these two statements we made by just observing. Did we require any proof? Did we tell someone, come and prove this? No. We directly accepted it as true, right? These are universal statements. These are universal truths. Doesn't require any proof, right? Now, such statements are nothing but that. Such a statement is called as an axiom. So what is an axiom? It's a simple statement which we accept as true and need not be proved, are called as axiom, right? So these are nothing but two statements which we learned as an axiom. And in today's geometry, in modern geometry, axioms are also called as postulate. Axioms and postulate in today's modern geometry is one and the same. But in Euclidean geometry, axioms and postulates are two different things. Both are general statements which we directly accept as true. But those were two different terms. Why? Axioms and postulates are nothing but they are universal truth, don't require any proof. But axioms are statements, properties which deals with, applies to entire mathematics. Whereas postulate specifically applies to geometry. But in today's modern geometry, we have both. We consider axioms and postulate to be one and the same. But we are discussing here something about Euclidean geometry, and he created 5 postulates, right? The first postulate, let's see that. Euclid's first postulate, what does it say? It says a very simple thing which we have already discussed. What is that? There are infinite lines passing through a point. You will say, yes, we know that. Through a point. How many lines pass? 1, 2, 50, 100, 1000? No, infinite. So we know the first postulate, right? In today's world, in today's modern geometry, postulate, axiom, one and the same, right? But he said this is a postulate, an axiom which deals with geometry. That's why he called it as a postulate, and that's the first one. Let's look at the second one. We know this too. What is that? There is one and only one line passing through 2 points. When we have 2 distinct points, how many lines pass through it? We know that it is one and only one. That means we know the second 2. Third one, it is even more easier because it is the postulates. We just look at it and we understand and we accept, right? Look here, a circle of given radius can be drawn taking any point as its center. It's so simple, isn't it? Yes, it is. Because if I have to draw a circle, I require a center, so I'll take any point as a center and I'll take the radius on the compass and draw it. I'm saying this is a circle of radius 3 centimeter. That means we are saying that here the radius is 3 centimeter and A is the center. So what have we done? We have drawn a circle of radius 3 centimeter. Taking A as a center. That means what we understand here is, for drawing a circle, what do we require? We require a point, fixed point, which is the center, and we require the radius. Let's say we draw another circle with C as the center, and here I have taken the radius to be 2 centimeter. Isn't that easy? This is something which we know, very simple. That's why these are statements which don't require any proof. That is why it is called as a postulate, but because it deals with geometry, right? Beautiful. Let's look at the other one. That's the fourth postulate. What is that? It's very simple again. All right angles are congruent with each other. Now you'll say that's so simple. Yes, that's why it's a postulate. That's why it's an axiom. Beautiful. If you look here, angle ABC, it's a right angle. What's the measure of that angle? 90 degree. Angle PQR, it's a right angle. What's the measure of that angle? 90 degree. If you look here, this is a square, and in a square, each of that angle is a right angle. Each of that is measuring 90 degree. It's a rectangle. Angle A, angle B, angle C, angle D. Each angle is a right angle. Its measure is 90 degree. That means you say, you take any right angles, it is congruent because their measures are the same. It's so simple. Coming on to the most important postulate, most important one, that is Euclid's fifth postulate. You need not memorize the statement. It's very easy to understand because it's a postulate eventually, right? Let's understand the statement. Let's go step by step. It says that if two interior angles formed on one side of a transversal of two lines, I repeat, if two interior angles formed on one side of a transversal of two lines, that means we require two lines. So we have here line L and line M, and we require a transversal for that, that is line N. That means it intersect at two distinct points, right? We are talking about interior angles. Now, when we know that two lines are intersected by transversal, what do we have? We have two pairs of interior angles. One on one side, the other one on the other side. So let's look here. So that means we know angle 1 and angle 3 is one pair of interior angle. Angle 2 and angle 4 is the other pair of interior angle. That's easy. We know that. Beautiful. What are they saying? If two interior angles formed on one side of a transversal of two lines add up to less than two right angles. When we say two right angles, one right angle is how much? 90 degree. So two right angle means 180 degree. So what does that statement mean? Add up to less than 180 degree. Now which one do you feel? Which pair of interior angle do you feel when you take? Its sum would be less than 180 degree. It's obviously on this side, the right hand side of the transversal. Let's see that. Angle 2, if you measure it with the help of a protractor, we happen to get it as 90 degree, okay. Angle 4, if you measure that with the help of a protractor, we get it as 80 degree. 90 plus 80, how much is that? You're talking about the sum. How much is that? It is 170. That means here, the interior angles which are formed on this side of transversal N, its sum is less than 180 degree. Okay, so we are talking about the transversal, this, on this side, we are talking about this lines, the angles which are formed on this side, interior angles. What does it say? Then the lines produced in that direction, in which direction? To the right. We have considered this one. Here the interior angles, their sum is less than 180. So we are talking about this side, remember. Then the lines produced means extended in that direction, means in this direction. Let's produce that, let's extend it. What happens? You see, they intersect each other at a point. And that's the concept which is very easily understood. We understood. Did we ask for a proof? We know, because we saw that here the interior angles, the sum is less than 180. We saw that when we extend that in that direction, the lines are going to intersect. From the same concept, from here, the concept of parallel lines came into existence. Now that is very important. You know how? If the interior angles, the sum is less than 180, then when we extend the line in that direction, what happens is we know that they intersect. Now, if we have the interior angles and their sum is equal to 180, then these lines will not intersect and they will become parallel. They will not intersect, they will go on extending, they will become parallel. That is how from this postulate itself we understood when are lines said to be parallel, right? And that is all because of the great Greek mathematician Euclid, who is considered the father of geometry. So wasn't that easy?